All right, we are continuing on here with part 2 of Unit 9 work. Again, that's Unit 9, 9, 9, which has to do with circles. All right, let's look at this one. Diameter, e.g. is a diameter. From here to here, that's a diameter. That means that it cuts a circle in half. That means that this angle in the middle, this central angle, is 180 degrees. That means that this arc right here is 180 degrees. So now I see something going on with these three arcs. I got this arc EF, this arc FG, and this third arc 180. If I put all three of those together, that makes a full circle. Well, let's use that idea. 9x plus 9 plus 14x plus 10 plus 180 equals 360. Okay then, let's start simplifying. Let's go ahead and subtract this 180, because I know what 360 minus 180 is. What's 180? So it means that the other two pieces, 9x plus 9 and 14x plus 10, add up to 180. So if I simplify that side a little bit, I'm going to have 23x plus 19 equals 180. If I subtract 19 from both sides, let's see what we get. 23x equals 161. So now as I'm looking at that, I don't know how many times 23 goes into 161. So I'm going to take a guess. Let's see, do you think it goes in 5 times? I think it would go in more than 5 times. In fact, I think it's going to go in 7 times. Let's try that. 23 times 7. 7 times 3 is 1. Carry the 2. 7 times 2 is 14. Plus the 2 is 16. 161. So x equals 7. Done? No! It says find the measure of angle GEF. GEF. So that's this angle right here. And that angle relates to this arc right there. Well, let's see. If we have 14 times 7 plus 10, let's see what that arc would be. 14 times 7 is going to be 98 plus 10. And then we simplify by adding those two together. That gives us 108. But this angle, there's no way that could be 108 degrees. There's no way. Oh, but remember, the arc divided by 2 equals the angle. In that case, whatever that arc is divided by 2 is going to equal, well, that arc is 108 degrees. Let's start with that. 108 divided by 2 is going to equal the angle that we want. 108 divided by 2 is 54. 54, 54, 54. So the answer then is 54. That's a lot of work. It's not necessarily hard, but it's a lot. So you've got to kind of keep that straight as you go. Let's try another one. Number 55 here. Okay, let's see what's going on. I got this angle. Then I got these two arcs. Well, if I were to multiply this angle by 2, that would give me this arc FE right here. So I know that 94x minus 1 times 2 equals that arc. And then if I add all 3 of those arcs together, that's going to give me a full circle. Let's try that. 2 times 94x minus 1. That's the big arc. Then we got 129x minus 1. Then the last one is just 46x. Put those 3 together, we get 360 degrees, a full rotation. So now I guess we got to start simplifying this. We got 2 times 94. That's going to be, let's see, 6 less, 12 less than 200. So 188x minus 2 plus 129x minus 1 plus 46x equals 360. Well, it's easy enough to subtract these numbers here, and I have a feeling that they're going to come out pretty close to the other number as well there. Let's check ourselves with a calculator. Plus 129 plus 46. 63. So E3x minus 3 equals 360. If I add 3 to both sides, then I got 363 times x equals 363. It's pretty obvious what x should be here. I actually wrote too many x, taking them back now. So if I divide both sides by 363, 363 over 363, that's a lot of 363s, but they simplify to just 1. X equals 1. So they want us to find DE, this arc. Well, that's a piece of cake. That's the simplest one to plug in. So we do 46 times x is just 1. That's 46 degrees. So measure of arc DE is 46 degrees. Next. Assume that lines which appear to be tangent are tangent. One thing we need to know about tangent lines, they make right angles. They are perpendicular to a radius. So when I look at this triangle, I actually see a right triangle. And if I look and I see a right triangle, that means I could do Pythagorean theorem. It's a relationship that comes with every right triangle. And in this case, we have 7.2 and the question mark are going to be our legs, and the 9 is going to be our hypotenuse. So let's start with that. 7.2, we're going to square that, plus the question mark squared equals 9 squared. I don't know what 7.2 squared is, so let's go ahead and calculate that. 7.2 squared. It gives us 51.84. 51.84 plus the question mark squared equals 9 squared, which is 81. Well, I got to subtract 51.84 from both sides. And that's going to give me 29.16, I believe. I'm going to check it with the calculator here, though. 51 minus 51.84. 29.16. Now I got to square root that. So let's go to the second, and then the squared. That's my square root. And second, and then the negative sign, and that's going to give us our answer. 5.4. So the question mark equals 5.4. Exactly. That was pretty awesome. It was decimals, but it still came out very evenly. All right. So now I got 5.6 as a leg and 3.3 as a leg. Now this other piece here, this is kind of interesting because the question mark only represents the outside. It's not looking at the whole thing. It's just looking at this piece right here. I'm going to color this inside part with blue. Now if you think about both of those put together, they make the hypotenuse. So together, these are the hypotenuse. But take a look at this. This is actually 3.3 inside there. How do I know that? Because they're both a radius. So now let's set up all those things together. I'm going to go ahead and call this question mark x, just for familiarity when we do equations. But let's set all this up. So we got our right triangle, and we got our two legs. So we got 5.6 squared plus 3.3 squared. So those are our two legs. That's going to equal the hypotenuse squared, which is x plus 3.3 squared. All right, so let's see what we got. 5.6 squared. That's 31.36, and 3.3 squared. So that's 31.36 and 10.89. Then over here I still have x plus 3.3 squared. I'm going to leave that alone for now. I'm not going to change anything to it. I'm going to add these two together though. I need to add the answer plus 31.36. That gives me 42.25. So 42.25 equals x plus 3.3 squared. I'm going to square root both sides just to get rid of that squared finally. Square root that. Second, square root our answer. 6.5. So 6.5 equals x plus 3.3. If I subtract 3.3 from both sides, that gives me 3.2 equals x. So that would have been my answer. But notice the key here as far as why was that one different? Because we didn't have a full length in a right triangle here. We just had this outside piece. So we had to find just a piece. And we had also recognized that the radius was used twice in the shape. All right, we got some easy ones now. Lines that look like they're tangent are tangent. And the cool thing about tangent lines, they're equal. It's that easy. It is that easy. So tangent lines, if they come to a common point, like this one on the outside, then they're equal. So 2x plus 7 equals 2x plus 7, pardon me, equals 3x minus 5. So then, we subtract 2x from both sides, add 5 to both sides, x equals 12. Done. Move on. 3x minus 8 and 2x, those two expressions are going to be equal. This 11.4 means nothing. Nothing to us. We're just trying to solve for x. 3x minus 8 equals 2x. So if I subtract 2x from both sides, add 8 to both sides, let's see what we get. We're going to have x on the left and 8 on the right. X equals 8. That was 2 problems. That's got to be a record, like 2 problems in 1 minute there. Next, now we're getting into the beefy ones. We're going to be doing a bunch of measures with arcs and angles. One thing to keep in mind is that the arcs divided by 2 equals the angle. We're going to keep coming back to that over and over again. So that means that the arc, which is 170, divided by 2 is going to equal our angle, or our question mark. 170 divided by 2 simplifies to 85. 85 equals the question mark, 85 degrees. So there's that one. Let's look at this next one. So again, we have the arcs divided by 2 equals the angle. Remember, I kept saying arcs. So right now, we have 2 arcs, and the angle is outside. Whenever it's outside, we're going to subtract the 2 arcs. So we got 80 and a question mark. We'll call that question mark x. So x minus 80 divided by 2 is equal to 35. So I got to get this 35, or this x actually by itself. So I'm going to multiply both sides by 2. Then I'll have x minus 80 equals 70. If I add 80 to both sides, I get x equals 150. 150 degrees is my answer for x, or the question mark. So that's 150 degrees. Remember to pause anytime if you need to change the pace. Rewind, fast forward. Looking for an arc on the outside, and we got this arc on the inside and the other angle. So it's those arcs divided by 2 equals the angle. So right now we have x minus 105. Notice that I'm using the bigger one first, that x, because the 105 is smaller. X minus 105 over 2 equals 50 degrees. So I'm going to multiply both sides by 2. 2 over 2 simplifies, and I have x minus 105 equals 100. Now I have to add 105 to both sides. That'll give me x equals 205. 205 degrees. Easy peasy. Whoa, something different. What's different? This angle, which is 51 degrees, is on the inside. It's on the inside. Therefore, we are going to add. If our angle that we're looking for, or that we're using in our relationship, is inside the circle, we're going to add the arcs. So we have one of the arcs is a question mark, so we'll call that x. The other one is 50. Put those together, divide by 2. We're going to equal 51. So we're going to multiply both sides by 2 to get rid of this 2 in the denominator. That gives us x plus 50 on the left equals, 51 times 2, which is 102. If I subtract 50 from both sides, then x equals 52 degrees. So So that's our question mark. That's our missing arc length here, 52 degrees. Moving really well here, but let's keep it up. Ooh, this one is on the circle. Now, it might not look like it, but it's the same type of thing as if we had a measurement kind of like this. So let's see what information we have and how we can put that together. We know that this blue arc right here, or this blue angle I should say, is related to this blue arc that I'm coloring in right now. And we don't know what that measure of the arc. We know that the arc divided by 2 equals the angle. So we don't know anything yet. But if I see that the other side is 190, this one that I'm just coloring in now in red, if that's 190, then I know that the blue one is going to be 360 subtract that. So arc ST, I guess you could say, I don't know how you would say it, but that arc ST in blue is going to be 360 minus 190. Well, 360 minus 190 is the same as 370 minus 200, or 170. 170. So this over here, that's 170 degrees. So I'm going to say 170 divided by 2 equals that angle, which is a question mark. I think we already did this once, but just in case, I'm not sure if we did. That would be 85. So the angle, the question mark, equals 85 degrees. Well, there you go. That's that one. Let's do another one. I notice that the vertex, the angles, are inside. So I'm going to add the angles. So I got, or add the arcs, I should say. So I got my arcs divided by 2, and that's going to equal the angle. So my two arcs are going to be 110 and 60, and those are going to be added up, divided by 2 to equal the question mark. So 110 divided by 60. How do we get that? That's 110 plus, or 110 plus 60 divided by 2. Pardon me. 110 plus 60 is going to be 170 divided by 2 equals the angle. This is kind of weird. We get the same answer for both of these, but they had different methods to start with. So this question mark is 85 degrees, as is the vertical angle on the other side of that intersection. Not something they asked, but still something that you might want to consider, because that's the kind of relationships that we look for in these measurements. We're moving right along here. We got 6 pages to go. Let's finish strong. Okay, this one is similar to before, where this is on the circle. It's not so obvious, but the vertex of the angle is actually touching the circle here. That's what tells us it's on the circle. So we're going to take the arc, we're going to divide it by 2, and that equals our angle. Well, the arc in this case is 70, and the question mark is our angle. So 70 divided by 2 is just 35 degrees. So that's the measure of the angle. This next one, ooh, this is interesting, because we actually have to solve for something in the arc, not into the angle. Sometimes it's harder to find the arc. Notice that we are inside the circle, therefore we are going to add. So I'm going to take the question mark plus the other arc, which is 117. And it's always that divided by 2 equals the angle, which in this case is 101. So I'm going to multiply both sides by 101, or not 101, by 2. I'm going to multiply by 2, times 2, times 2. So on the left side, 2 over 2 simplifies. So the question mark plus 117 equals 101 times 2, which is 202. Subtract 117 from both sides. The question mark is equal to, let's see, that's going to be 75? I think so. 75. Let's double check just to make sure. So we have 12 minus 7, that's 5. Then 19 minus 11. Is that 85 then? I think maybe it's 85. We have a calculator. Let's use that. 202 minus 117. 85. So it's 85 degrees. You guys are probably shouting at the screen saying, Mr. Butler, you can't even subtract. 85 degrees. And we're moving on. Okay, now we're looking at segments. The directions weren't here, but it says find the measure or solve for x is actually what it's saying. It's saying solve for x. And this involves segments. And for segments, the relationship is always going to have two things multiplied equal two more things multiplied. So we're always going to come back to that. Let's see what we come up with. Well, for 81 here, when we are on the circle, because we have a segment right here, this one that measures 12 is on the circle. It's the same thing actually as if it was out of the circle, and we have secant lines. So let's look at that. That would be, it's always going to be the outside piece times the whole equals the outside piece times the whole. Well, in this case, the outside piece, if that were 12, well, the whole length is also 12. Similarly, this other outside piece is 9, but the whole length is going to be 9 plus x, the entire length, both pieces added together. Let's simplify that. 12 times 12 is going to be 144. And then when we distribute this 9 to the 9 and the x, that gives us 81 plus 9x. We subtract 81 from both sides. That's going to give us 63 equals 9x. We divide by 9, divide by 9. 7 equals x. So that wasn't too bad. Came out evenly. Let's check out this next one. I don't know if it's going to come out so evenly with this one. So again, we have this relationship with the outside times the whole equals the outside times the whole. Well, the outside in this first one is 9. And the whole then, the whole length is going to be 9 plus x. Then the other outside is 8, while the whole is 8 plus 19. 8 plus 19 is going to be 27. So let's start simplifying. We got 9 times 9 is 81, and 9 times x is 9x. On the other side, we have 8 times 27, which is really 4 times 3 is 12, and then 2 times 3 is 6. Let's just use a calculator. 8 times 27. 16. So we're going to subtract 81 from both sides. We'd have 9x equals, that's going to be 5, and then 21 minus 8 is 13, 135. We divide both sides by 9. How many times is 9 going to 135? That's kind of crazy. I think it's going to be 15, but let's just double check just to make sure. 9 goes into 13 once. And we're going to go into, we have a remainder 4. 9 goes into 45 5 times. So it's x equals 15. Excellent. It's kind of crazy. I did not expect it to be that short. I was actually thinking it'd be closer to 19. Oh well. Let's keep moving. All right, notice segments. They're not outside the circle, they're not on the circle, they are in the circle. So this time we're just going to have a piece times a piece, the two inside pieces of the same line equal the other two pieces times each other. So we don't need the whole line at all. So let's set that up. That means that we got x times 7. And then on the other side we have 8 times 14. It doesn't really matter which order you put it in, 14 and 8, 7 and x. But when we simplify here, we'd have 7x. And then 8 times 14, which is really 56 times 2, or 112. When I divide both sides by 7, now let's see what happens. 7 goes into 112 once, and that gives us 7. We have 42, and then it's going to be 16 times. So x equals 16. like magic. All right, for this next one, we are outside the circle. So again, we're going to have that outside times the whole equals the outside times the whole. So let's do blue and red, just to color code. We're going to do the outside times the whole. That means we have 7 times 7 plus x. Then on the other side, we're going to have 8 times the whole, which in this case is going to be 21. 8 plus 13. So 8 times 21. So now if I simplify this, that means we're going to have 49 plus 7x. And on the other side, 8 times 21, that's going to be 56 times 3, which is 168. I think, but let me double check just to, oh yeah, it's 168. 49 subtracted on both sides is going to help us simplify. So we'll have 7x on the left side. And on the right side, let's see what we have. 18 minus 9 is 9, but we borrowed here, so we got 119. So now I got to divide both sides by 7. Now here's something. I know that 7 times 16 equals 112. And if I add one more 7 to both sides, that means it's going to be 17 sevens. So I'm actually using the information from the previous problem to help me simplify this side. In this case, x is going to be equal to 17. I don't know if you caught the reasoning going on there, but if you use the calculator, you'd get the same answer just to check. But let's keep moving. We got 3 pages to go, and we are almost. Find FH. So it's find the measure of the line segment indicated. Not only do we have to solve, but then we have to evaluate. And evaluate means to find the value. So we're doing more than just solving an equation. Okay, so we got 9x plus 1. I'm guessing that represents this side right here. So that means that 9x plus 1 is going to be multiplied by the other piece, which in this case is 18. And then the other two pieces are 9 and 20. So those are going to be equal to 9 times 20. So we got a lot of simplifying to do. On the left side, that's really going to be 162 x plus 18. And on the right side, that's going to be 10 times 9 is 90, times 2 is 180. Okay, let's go and subtract 18 from both sides. That would give me 162x equals 162. So if I divide by 162, it should be obvious at this point, but that's going to give you x equals 1. Okay. That's helpful, but now we got to plug it in because it's asking us to find FH. Well, FH is the whole side here. We know that 9x plus 1 is going to be 9 times 1 plus 1, which equals 10. So that tells me that this piece here is 10, and the other part of it is 18. Together, they make 28. That would have been the answer to that. Number 91, it says find the measure of BD. That means this length here. So not only do we have to find x minus 7, or x, I guess you could say, but we have to, evaluate it by plugging it back in. All right, so now we have something that's outside the circle. That means our relationship is going to be out times the whole equals the out times the whole. So let's put those pieces together. Let's start with the black. That's going to be 6 times the whole is 6 plus x minus 7. There's a lot of simplifying going on in that one. Then the other one's a lot more straightforward. It's just 5 times 5 plus 7. Go ahead and take an extra step here to simplify that. That'll give me 5 times 12 on the right. And on the left, though, it's going to be 6 times 6 plus x minus 7 is really x minus 1 if I combine like terms. So now if I simplify both sides, 5 times 12 is 60. And And this side's going to be 6x minus 6. We got lots of 6's all over the place. Add 6, add 6. 6x equals 66. We still got lots of 6's. Divide by 6. X equals 11. That's helpful, but now I got to actually plug that in. That means that this short piece here is 4, because 11 minus 7 is 4. And the whole length BD is going to be 4 plus 6, which equals 10. BD equals 10. All right, now let's look at the next one. These ones, we got circle by the center of each of these circles. Well, here's something that you need to know when you go into this. There's a format for the equation of a circle. It's x minus h squared plus y minus k squared equals the radius squared. And h comma k represent your x comma y center. And notice that here this says minus. So that's really meaning that it's kind of like the opposite of it. So if this says plus, that's like saying minus minus 2. So h is really negative 2. And y plus 4 is really minus minus 4. So k is really negative 4. So my h comma k center is equal to negative 2, negative 4. The radius, this is even crazier. This says r squared here, so 3 equals r squared. That means that r equals square root of 3. That's going to be kind of hard to estimate there, but let's do our best. So that means our circle is going to be at negative 2 and then up or down 4. Now we got to approximate square root of square root of 3. That's just over 1, so we'll say it's about here in each direction. So the circle looks about like that. This next one, remember we're taking the opposites of these numbers. So that means that x is really equal to negative 3 and y is equal to 4. So I'm going to go out negative 3 and up 4. There's my center. Now this one has an easier radius. If r squared equals 1, then that means that my real radius is also 1 because the square root of 1 is 1. So we got a couple of small circles going on here. They're not always this small, but these two are. There we go. Let's take a look at the next ones. Okay, now we got. We know that we need to have x minus h. So we need that x center. The x center. And we're going to have y minus k. That's going to be our y center. And then r squared. So we need the radius as well. So let's start with the x center. The x center looks to be right about here at 3. So there's my h. And k is right here at 1. So that's my k. So it's going to be x minus 3, there's my h squared, plus y minus 1, there's my k squared, equals the radius squared. Well, in this case, the radius goes from 1 over to 3, and that distance is 2. So equals 2 squared. That's it. It's just recognizing them together in a way that makes sense. Let's look at this next one. The center looks like it's here. That means that my h is at negative 1, and my k is at 4. And my radius, again, is 2. So my x minus h squared plus y minus k squared equals r squared. Okay, so h is negative 1. So this first term is going to be x minus negative 1 squared plus, then the next term is going to be y minus 4 squared. And then the radius in this case is 2 again, so that's 2 squared. Now to simplify this so that we would know what it would look like on a multiple choice test, you don't see double signs. They always combine them. So it's going to be x plus 1 squared equals or not equals, where am I coming up with equals? Into the video and we're getting sloppy here. X minus 1 squared plus y minus 4 squared, no simplifying there, equals 4. That would be the multiple choice answer simplified version. All right, done with video part 2. Hope you enjoyed. Keep on studying, keep on practicing, and good luck with the tests.